And I had this idea of a talk while writing this. So it's not a tweet. It's a blue sky content stuff. And I just thought, wow, there is something very stupid I could do. Like, I want that my PR, my own GitHub workflow, Jenkins, whatever, runs the end-to-end test on my target Kubernetes environment. I mean, that's the basic, right? You want to make sure that the code you are merging works as expected. And for that, you need to deploy everything. And as you can see, it took me 85 attempts to do that. And, well, I'm not the best engineer around, but I'm not the worst either. And I thought, there is a lot of content here that can perhaps use to help others do the same. Well, not the same, like in many, many these runs. So why am I talking about this? Because a long time ago, I wrote a book on integration tests. And at the time, I had very big ideas. But those are a couple of them. The first thing, why would you run integration tests compared to unit tests? Because integration tests are closer to the final environment, to the target environment. Closest to the environment means more confidence in the tests. Like, all your unit tests might be amazing, but it might not run into production because of something you completely forgot to test in your unit test. In the book, I was super specific that an integration test was anything that involved the collaboration of two classes, if we are talking about Java. Who here is not a Java developer? What stack? C#, that's fine. And you? Python. Python has classes, C# has classes. So basically anything that tests the collaboration of two classes, for me, was an integration test. Over the years, I've changed my views a bit. For example, Google at the time distinguished only between fast test and slow test. And in that case, I would say this is a slow test. For example, in the Java ecosystem, now we have test containers. So it makes the testing of something with a database or anything related to another piece of infrastructure much faster than it was in the past, especially if the image is already there. So you might see it as an integration test, but it runs quite fast. So here is what I want to test. I have an app. I have an integration test, obviously, at least one. I have a target cluster and a continuous integration pipeline that runs when you submit a PR. So those are the 4 raw components that I will use. And here is how I will use them. What's the implementation? So it's a Java implementation because I'm at the Dublin Java user group. But I've done a workshop that is very related to that, and it uses a Python application. And you can do the same with any technology, C#, whatever. I will also use a Postgres database just to make things a bit more real. My app will offer REST endpoints, okay, which is not far-fetched in the current ecosystem. And it's an e-commerce app. It's not really a commerce app. It just gets data from a database. It gets all items. It counts them. It adds one more using the APIs above, and then it counts them again, and it needs to have +1. And that's really an amazing and crazily hard engineering problem. I'm targeting Google Kubernetes Engine. The reason for that is I know it the most. There is no other reason. You might use anyone you want. It doesn't need to be remote, actually. It can be hosted in your infrastructure. It's just that I know Google the most and not that good. And I will be using GitHub and GitHub Action because, again, that's very, very widespread and I know them quite well. In the past, I used Jenkins. For my blog, I'm using GitLab. So anything is fair game. You can transpose what I will be explaining here to your own implementation. The first thing is, where do we create the Kubernetes cluster? Basically, you have two choices. The first one is we create it upstream. Okay. The second choice is we create it during the workflow. So I assume everything is automated. If we create it upstream, it must be big enough to accept every pull request that comes. So far, so good. Okay? Now the thing is, there is a tension between different factors. The first is money. So imagine you have a huge Kubernetes cluster running all the time. It doesn't cost that much, actually, because you only pay the control plane cost. But then when people actually send their workload, this is where it runs. And you need to make sure that at the end of the pull request, the workloads that it's created is deleted. Okay? Speed. If you create the cluster during the workflow run, it takes a long time. On GKE, for example, it takes between 5 and 7 minutes to create a small minimal cluster. So either you have something running all the time, or you have something that you create ad hoc, but it takes more time. Meaning that your engineer sends a request, waits for ages, so they do something, and then it fails, and they need to switch context again, which is probably not what you want to have in your engineering teams. And isolation. If you have a huge cluster, how will you isolate every PR? How do you isolate different workloads on Kubernetes cluster? Namespaces, yeah. Everybody is doing namespaces. And that's a very good first level approach, but it requires you to have a lot of permissions regarding the namespaces. That is operational complexity that you can also automate more or less. But now comes the real problem. What if the objects that you are testing are not namespaced? CRDs are not namespaced. So if one team decides to try to upgrade the CRD version, then they will crash the other PRs. Or there is a risk that they will. And so in that case, you need to think, okay, these PRs, I need to run them somewhere else. And again, you have operational complexity. This is summarized here. You have a single upstream cluster. You have weak isolation via namespaces, problem of CRDs, and something I didn't mention, there is a chance you will have conflict of ports. Second one, you have one cluster per PR. Well, obviously, it's going to take a long time. So if your cluster takes 5 to 7 minutes and having an existing cluster takes 0 minutes, then you multiply this number, let's say 6, by the number of PRs, and then you see all the time that you are wasting, which is not great. What if we could have something that is just in between, that has isolation and just is created very, very fast? So not as fast as nothing, but quite fast, let's say 1 minute. Would that be a good, average for you? Well, I hope so. And so I work for a company called Love Labs that we do exactly that. We create virtual clusters inside of your host cluster. So what I will do in this talk is I will use this big upstream cluster that is running all the time. And basically, I checked for my cluster, the control plane running all the time costs about $80 per month. So what I will be doing is I will create the virtual cluster during the workflow. Takes, let's say, 1 minute, more or less. It's completely isolated because once I create the virtual cluster, I run everything inside of it. I see nothing outside of it. I run my stuff. I delete the virtual cluster. It handles COD version conflict. It handles port conflict.
IIS is a technology company that's focused in the verification space. We basically develop technology solutions around a few different kind of core areas. The main ones are brand safety, fraud, and viewability, but we have a number of other products that sort of branch off of those.
The mission behind the company, I love working towards a larger goal to help the ad ecosystem as a whole, to help fight fraud. I love the mission behind it.
IIS is in a business of trust and transparency, and I think that filters down through the day-to-day of the employees. It gets in the culture and sort of infuses the whole thing.
We're really an agnostic company that works with people on all different sides. We'll work with publishers, we also work with brands, we work with agencies, we work with DSPs, and I think as a whole, we're just trying to move the industry forward in terms of developing solutions that make us as a whole more transparent.
The people are happy, friendly, and there are like happy hours, fresh fruits that we have in the kitchen, the flowers, team building activities. So these kind of sorts of things that really appreciate.
We have offices all over the world. We have Tokyo, we have Singapore, we have Australia, we have a dozen offices in Europe.
Every day is really different here. So some days I'm training clients, some days I'm troubleshooting all sorts of issues, and because I work with all sorts of stakeholders, I never really know what to expect.
People at IIS are really great. They're young, they're forward-looking, they're super resourceful. I would say they're a great bunch of people to work with, and really I think staffing is maybe one of the strongest points of this company.
I'm most excited about the continued growth of the company. So we're really trying to scale up our R&D department, but also more broadly. So I'm interested to see the impact of that on the business and the areas that we'll continue to grow and invest in. So really excited to see where we go.
So for my approach, I'm lazy. That's the reason for the picture. I don't want to go into the details of everything I did on GKE because the idea is not to describe GKE setup, more about the GitHub action workflow. That is important. I will also like, here it's a Java group, user group, so I can show you the details of the app, but it's not necessary. And I will use GitHub Workflows and as many actions as possible because I don't want to write bash or anything. The workflow is the following. I have an app. So what I will need to do is I will need to build a container. Then I will push the container to the GitHub container registry, so I can use it afterwards. I will create the virtual cluster in the GKE cluster. Then I will deploy the container, and I will run the test on the deployed container. I mean, that looks super simple, right? 85 attempts. Let's try the beginning here. Obviously, does it work here? Yeah, it works. Every pull request that you want to merge on master. Obviously, it depends a lot on how you are using it. But here, I assume that it's a regular, simple Git workflow. You have feature branches, you merge them on master. Perhaps not what you are using. If you are using another strategy, obviously you need to change it. And especially at the beginning, you need to allow somebody to click run workflow because you will need to debug a lot. So you don't want to send 85 pull requests. You just want to send one pull request and test it by clicking test workflow. That's the foundation. Second, we need a couple of permissions. Well, easy peasy. We need to be able to read the repository, to write the package, and to use an ID token because we will need to be authenticated. But so far, that's quite straightforward. Here, if you want to be very clean, you can have environment variables so that you can easily change your infrastructure. For example, here, I'm using an environment variable to say, okay, I will use GitHub container repository. If I want to change to something else, I can just change the environment variable. Here, something important. How long will you keep the image? So that might be important to you. That's either you put nothing and it will be unlimited, but for a pull request, I'm not sure it's a great idea. Or a couple number of days so that if something is wrong, you can check the container, download it, and use it locally. First step, check out the repository. Now comes the fun part. Remember, we need to build the image and we need to push the image to the GitHub container registry. So the first thing to do is to log into the registry so that when we push, it will be the registry we push to, we will be authenticated, it will work. The end.registry, remember, is the one we defined here, right? The username, there is an existing variable, GitHub actor, basically the person who actually did the pull requests. And the password is the GitHub token. It's an implicit secret that every workflow has. So now each workflow, so each PR will start a workflow. Each workflow will create an image. In general, what you do for regular deployments, you have the image name and the image tag. The image tag is the version. Here, obviously, you can't use a fixed version because you will run different pipelines in parallel and you don't want them to overwrite each other. So we need to have a unique ID. There is something on GitHub called the run ID. So you can use a random one and that would work. But then you need to find a way in your YAML to generate a random number, which is not that fun. This one is unique per run. So just choose it. And now we have this nice action, metadata action. So we will tell it, okay, this is the image that I want to generate. It needs to be prefixed by the registry. Then you have the repository name, or you can like set something different. Here, again, I'm lazy. I just want to use something existing. And you can add a tag, which will be appended afterwards. And here, I'm using the GitHub run ID. If you use it for production purpose, check this action. It's very interesting. It gives you a lot of different types, so you can generate the tag depending on a lot of different things. Here, I'm using the one that I want, which is the role. Afterwards, build and push action. So we are authenticated because we logged in before. The context is this one, like the current directory. That's the reason why I'm using a Docker file. I don't need an additional like action to say, I don't know, Spring Boot build image or whatever. So it will build the image through a Docker file for me. And here, steps.meta.output.tags is what? If we check, you see this action had an ID, which my previous action didn't have. The reason for that is now I can use it in later stages and use what their output was. So here, nothing happens, but it gives you the result that it will create something called, output.tags. It also gives you some labels at output. I didn't change anything. You know that in Docker images, you have like some generic labels. So who created the image, when what is created, this kind of stuff. I'm using the ones that are default because it's good enough for me. Okay, and then I push.
Let's face it, with traditional recruitment agency models, you're exposed. If a candidate leaves any time during the first 12 months, you and your team will experience major pain. That's why at Stack & Co, we've created a win-win risk-sharing hiring model where we share the risk with you for the first 12 months and allow you to spread your hiring budget out over that time period. Furthermore, in the unlikely event of a Stack & Co candidate leaving any time during the 12 months, the payment obligation stops. Being software recruitment experts, we'll introduce you to the best engineering talent available in Ireland today. Reach out to me, Jerry Nolan, for more information via our website, stack&.co.
So good, we have the image created. Now comes the fun part. I want to deploy on Google Cloud. So I told you I don't want to tell you about the specifics, but in this case, I need to tell you a bit about the authentication scheme of Google Cloud. Who has already had fun with this kind of stuff? Sorry for you. It's a pain. Yeah, I don't know if other cloud providers are as painful as this one. Okay. Yeah, I don't know, but so basically, you have a service account. The service account is an ID that you create and is not tied to a physical person. It's just something that will be an identity. The identity provider manages different identities from external providers because you can not only have GitHub, you can have different ones. And then you have a pool, a workload identity provider pool that allows you to configure a specific provider. In that case, our provider will be GitHub. This is how they are tied together. A service account may have different roles. Every role has permissions. Service account will be tied to a workload identity pool. Here you have the provider, and here you have our friend, the Octocat. So basically, the idea is you will be using OpenID Connect. And you will need to match what OpenID Connect returns from GitHub to the Google internal attributes. This is pretty straightforward, actually, right? Here, Google subject is assertion.sub. Attribute actor is assertion.actor. You have the whole documentation online that tells you this is what Google expects, this is what you should set when you are using GitHub. That is pretty easy. The problem is, in the latest 6 months, you need to add a condition. Because you want to restrict, well, you want, perhaps you don't care, but Google wants you to restrict the permission to even more so that not everybody can deploy to your cluster. Here, for example, I'm saying the condition is that the actor, the one that actually runs the pipeline, is Fränkel, which is my GitHub account. You probably don't want to do that. What you want to do is to say, I want to accept something that comes from this repository. Or you want to say, I want to accept that it comes from this repository owner. Okay? So that anything that comes from any repository of the owner would be valid. So don't do the actor, I just did it because I was lazy. This action allows you to set the workload identity provider, which you see is a very, 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 very long chain of character. So project number, every Google project has a number associated to it. It's not the project ID, it's really a number. Then location global, you should always have global as a location. They require you to have a location, but at the moment the only value is global. Fun stuff. The identity provider name and the pool provider name. And then a service account as an email, so you set the email as it is here. And now, from the GitHub action, you're able to use your Google Cloud project. And probably you should have a project on Google Cloud per project. Or perhaps you can have a project on Google Cloud per team. I don't know about the topology that you want. It's up to you. Okay, that's great. But now we want to actually not do anything with Google Cloud. We want to use the cluster that we already have. So you need to set the cluster name and the location. What I did before you arrived is here, I created my cluster. So I created a minimal cluster, enough so that it runs everything I want. And here I set Europe West 9, because I'm not rich, I set it to a single node, right? What did I wanted to say as well, and the name of the cluster. So with that, we have the project name, and there will be this cluster in this project name, so we are able to use it. So here we have it running. Huh? Here is something very important at this stage is check it works. Because at this stage, there is a high chance you misconfigure something. So that's why you need to set the run to manual to just click, run it, check if it works, read the error message, get back to your workbench, blah, blah, blah. At this stage, at some point, you will see all the nodes and you will be the happiest person in the universe. It will probably show something like this. So here we are on the GK cluster, and even if you didn't run any workloads, you will see lots of different pods already running. Okay, so I told you this is great, but the problem is we have no isolation and we need workspace. So here I want to use vCluster. I install vCluster. That's one of the most straightforward way to install it. There is an action. We already have kubectl, so we don't need to install it. Virtual clusters, they also need to have a name. And so we will be facing the same problem as before. We don't want two parallel workflows to create the virtual cluster with the same name. Guess what? We already have a unique ID. We will reuse it. So here we say that the vCluster, right, will be named vCluster pipeline GitHub run ID. Here I was not smart enough to reuse the name of the project, but you can do the same. Next step, we need from the cluster, from the virtual cluster, to download the image from the registry. How do you do that? You need a secret. So we will create a Docker registry secret that has all the information that we need to actually be able to download the image. Why do I dry run client, put it in YAML, and pipe it to kubectl apply? for one single reason that might not be apparent in this stuff, but if you create a secret and it already exists, then you will face an error. This way, I apply these secrets, and if it already exists, it will overwrite it, and it won't create any error. Now, I told you I wanted to have a bit more fun because I wanted to install a database as well. You need to do the exact same. So create either secrets or config maps or whatever. Here you could use secrets, but you could use config map as well because you just create the database, do your stuff with the data, and remove the cluster afterwards. It's not production. So it's exactly the same. Well, I installed Postgres with the Helm chart. No really mind-blowing. Now we have a problem. The problem is we need to deploy the app. To deploy the app, we need a manifest. The manifest references an image. But again, the image will be different at every run, because remember, the image name is constant, but the tag depends on the workflow. So how would you do it? So the sysadmin way is said, quick and dirty, it works. Oh, I need to be fast, there will be pizza. And then there is a cloud native way, which uses customize. So in order to have the customized way, you need to set a customization.yaml in the exact same folder as the manifests and have this kind of like, woohoo, and I've lost it again. Here. So here I say, okay, whatever happens, it needs to be GitHub run ID. And then you apply the manifest with -k for customize. The quick and dirty way is, well, quick and dirty. If it's simple, I would advise you to just use the quick and dirty way. If it's more complicated, then perhaps use customize. We will deploy the stuff, the correct stuff. We have deployed the database. What do we miss? We miss to expose it from the virtual cluster to the GitHub action. So how do you do it generally? You have something called a load balancer. So I created a service type load balancer. And indeed, Google will give me an IP. But the problem is, if I do like this, what will happen is, so here, what I'm doing is I get the IP and I put it in the GitHub environment. If I do like this, it doesn't work. It actually takes time for Google to assign me the IP. So everything in the workflow runs sequentially. And if I run it, then no IP. So now I've got the IP. Any sysadmin here? Fun stuff, right? So I wait until I get the IP. Now I've got the IP. But the problem is I've got the IP. Who tells you that the app is ready? But even if the app, even if you have the IP, so the service is ready to serve, but the pods behind is still doing some shit. So it doesn't work. In order to be sure that the test runs correctly, we need to wait until the pod is ready. And for that, we have this amazing action, wait for X. Well, the action is Docker run action. But the container we're running is something called wait for X, and it allows you to wait until something is ready. It can be like a database, it can be the app, it can be anything. So we are telling it, and it means that we need to have an health endpoint, which is good because, well, we are probably using Spring, and Spring has an health endpoint. And until this returns 200, it stops the workflow from continuing. Afterwards, something very important, you don't want to clutter your cluster. In order not to clutter your cluster, you need to remove the virtual clusters that are not needed anymore. So you need to clean them up. How do you do that? vCluster, delete vCluster, whatever. Who can spot the issue with this? It doesn't work because if something happened in the previous stages, it stops the workflow and it doesn't clean up the cluster. So we need to say, in any case, we want to delete the cluster. But who can spot the issue in this? So there is no cluster, and still this step will run and will fail. So we need, when we created the virtual cluster, I also set an ID. I didn't mention it, but there is an ID vCluster. And in that case, we could reference that step and say, if this step conclusion is success, then delete the vCluster. So you must have always and whatever. 85 attempts. I kid you not. Do you want to see the result? Yeah. Everything that I told you is happening. So here, if I am local, I will initialize my database, like locally. I run with profile local. I will like set up my database in the code. Otherwise, I will use, sorry, not this one. I will use the amazing Flyway. Do you know about Flyway? Yeah, amazing stuff. So very good integration. I have all my migrations here. I create an extension just to be able to use a new UID. Then I create the table. Then I will initialize the data. Amazing, right? So then I create the product handler. And here I have a co-router with all my gets and my posts. And then I have my like regular like unit test. And then I have my end-to-end tests. Funnily enough, they are named exactly the same. when inserting a new product, there should be one more product in the database, and the last inserted product should be the one inserted, right? But here, I'm actually using it as a unit test. So using the Spring test framework, whereas in the end-to-end test, I'm using the unit test stuff. And here I'm using the integration tests because I need a base URL. Okay. The final pipeline is more or less what I showed with stuff specific to Java. I'm installing a GRE. Something that might be interesting to you as well is you can do some testing by having not to deploy a database on Kubernetes. So you are less close to your target environment, but you can have images inside of your GitHub workflow. I learned it by creating the blog post. I didn't know about it before. And the rest is exactly what I've showed you. First, I run the unit test because you need to fail fast. So if the unit test doesn't pass, why should I run the integration test? Then all the same is what I've shown you. And now, my friend, I run the workflow manually because I added it for that. Again, you shouldn't do it when it runs flawlessly, but at the beginning, it's very nice. And we give it a few seconds, and we can read about everything.
If you're exhausted before you even get to your desk, then check out T-Cube co-working space. Located at O'Connell Bridge in Dublin city centre means a maximum walk of just 3 minutes from over 100 Dublin bus routes, Dart Station, and both Red and Green Lewis. And after a long day of code crunching, getting home or meeting friends for dinner is also a breeze. We offer a low-cost, no-frills model, which means you're not paying for free stuff that you'll never use. T-Cube offers a range of flexible daytime and 24/7 options, meaning you can join our community of freelance and remote software developers from as low as €277 per month. And that includes VAT, coffee, and 1 gigabit Wi-Fi. So if you're looking for a distraction-free workspace, which you can come to and then get out again to enjoy your life in the comfort of knowing that you've been at your most productive, then get in touch today for a free trial. Call us on 675-9777 or find out more online at tcubedublin.com.
Oh no! Oh no! Always, always. What is telling me? And of course, it's in the here. Probably what's happening is it didn't get me the IP, which is very weird. So let's see. Yeah, I think the prefix is gone. So I don't know what's happening. It worked yesterday. But at least I can show you that it deletes the virtual cluster. Two things. First, some improvements that you might consider. I'm using the Ubuntu latest base image, which might be too big. Yeah, very heavy. So perhaps you want only an image that is custom for your build, then you don't need the full-fledged stuff. And here I actually use the caching in my real workflow, and I didn't show the caching here. But yeah, think about caching because it can really speed up your build as well. So thanks for your attention. You can follow me on Blue Sky. You can follow me on Mastodon. Well, if you really want to follow me on the Dying Birds, I'm still there anyway. If you're interested about the codes, check it. I put a bit.ly link so that I can see how many people did actually open the link, which is always fun. And then if you like the product and if you want me to come next year with the same company, please have a look at love.ch so that my boss sees that I'm doing something useful and I'm not paid to actually drink Guinness.
Thank you very much.